Today's car is made of more and more fiber-reinforced plastics. These composite materials offer engineers a broad new palette of options for replacing conventional low-carbon steel with lighter, more efficient material. But unfortunately, few engineers take full advantage of fiber-reinforced parts. They tend to over-design these parts. This often results in conservative design, which leads to added weight, inaccurate predictions, numerous test iterations, and greater risk of product failure. Let's see what MSC Software's Digimat is doing to help manufacturers with these problems. Structural engineers have traditionally dealt with a single material, such as metal, in the design of vehicle components. The metal material is consistent and predictable throughout the structure. This is referred to as isotropic. The stress-strain relationship and stiffness is consistent, and the manufacturing process has a minimal effect on the part's behavior. However, unlike the strength of metal parts, which is consistent throughout the part, the strength of parts designed with fiber-reinforced plastics can vary widely in different areas of the material. Let's take a more detailed look at how MSC Software's Digimat produces a much more accurate prediction of composite behavior. Parts manufactured with composite materials are typically comprised of a fiber material and a matrix material. Thus, the strength of the part is dependent on the following factors: the property of the fiber material, the property of the matrix material, and the size and shape of the fibers, such as their thickness and length. Moreover, with fiber-reinforced plastics, the manufacturing process itself also contributes to more factors: how the fibers are distributed in the matrix, such as local density, as well as the geometric orientation of the fibers as a result of flow forces in the injection mold. Most finite element analysis does not take into account these complex factors. Without using Digimat to accurately model the material, engineers treat anisotropic properties as isotropic, and the simulation will produce results that are inaccurate. This can be seen in the following graph. The blue line represents the actual experimental measurement. The green line represents analysis of the part incorrectly assuming that it has isotropic properties. The variance in these results is more than 80%. Let's take a look at how MSC Software's Digimat produces a much more accurate prediction of composite behavior. Digimat is an advanced material modeling and simulation platform from MSC Software. Digimat takes into account the complex variables associated with composite materials and produces a virtual material model that FEA programs can utilize during the simulation process. The virtual material model takes into account the individual properties of the composite materials as well as the more dynamic variables produced during the actual manufacturing process, such as fiber orientation. By accounting for these factors, Digimat can now produce accurate information to your finite element analysis software. With Digimat in the loop, during the simulation process, the FEA program can utilize Digimat's virtual material model to create much more accurate models, along with more precise simulation. This can be seen in the results represented by the red line, which shows analysis which uses Digimat's virtual material model. By using Digimat, our results match very closely with the real-world experimental measurements. The benefits to engineers from using Digimat include increased accuracy in materials testing, optimized design, which leads to lighter weighing parts, more accurate predictions of materials and part behavior, reduced testing and costs, fewer post-release recalls, and reduced risk, pre- and post-manufacturing. Digimat can bring significant value to your product design process. Let us help you get started today.